Okay, we introduced you in the previous homework to factorials, which I know some of you might be judging me that I had you do factorials before teaching it, but one of my best experiences was with a teacher that would do things like that, like introduce the next idea in a homework problem and then explain it, which I had a lot of fun with, and maybe you did as well. But anyway, that's what it's called when we put an exclamation point after a variable or after a number. It's called a factorial. So n factorial. Now I defined it a little bit differently. I start with a number and then I start counting down until I get to 1, and then I stop right there. And notice that n has to be a positive integer. So there's several examples on your page right now with 4 factorial, 4 times 3 times 2 times 1 is 24. 3 factorial, 3 times 2 times 1, 2 factorial is 2 times 1. There's also a special case in here, and that is 0 factorial, which is needed in probability. You need to know that 0 factorial is a numerical value, and it's a special case because 0 is not positive, but it is necessary to come up with some rules in math, and I hope you're okay with that being a defined value. So the reason why I called this section Fun with Factorials is that you don't have to actually know 8 factorial to get this answer. All you need to know is that 8 factorial is the same thing as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And honestly, you don't even have to write the times 1 because multiplying by 1 is not going to change the value of it. But the reason why that's helpful is because then, I'm just writing all of this out, everything is being multiplied, and I think it should be pretty clear for you that you can say, okay, well, the 6's will cancel, the 5's, the 4's, the 3's, the 2's, and yes, even the 1's, but it's not going to change anything. And how I typically do this problem is I look at this and I say, well, 2 goes into 8 4 times, so this answer must be 28. Now, I do know that some of you like to check your work, and I'm not ignorant to your calculator having this tool. So I want you to practice doing this without your calculator, but you are welcome to check your work with your calculator. And it's just under the math tool. If you go over to probability, yes, you have an exclamation point to do these problems. There might be a faster way to find factorial, by the way, because I don't typically use this tool to come up with the answer. But it does give you the correct answer of 28. And by the way, sometimes what you'll see me do is instead of writing all of the numbers down, what I'll do is I'll leave them as factorials, 2 factorial, but I'll change 6 factorial to be 6 times 5 factorial. Because, if you think about it, 6 times 5 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as 6 factorial. And the reason why I leave things like that alone is because then I can rewrite 3 factorial as 3 times 2 factorial. I can leave 5 factorial alone, and I can quickly look at that and say, okay, well, the 2 factorials will cancel, the 5 factorials will cancel, and 6 divided by 3 is 2. So to me, this is fun stuff. It's also because you can use a calculator on some of it. I'm not too concerned if you are struggling with these shortcuts, because I know your calculator will do the math for you. Where I'm more concerned is when you have problems like this. And the way I like to do this problem is, remember, n factorial is the same thing as n times n minus 1 times n minus 2 times n minus 3. And you might need some help because I'm very familiar with this, that if 6 was n, 5 is n minus 1, 4 is n minus 2, 3 is n minus 3, 2 is n minus 4, and so on until you get to 1. So maybe I'll even write all of that out until I get to 1. Well, if you look at n minus 1 factorial, well, that's n minus 1 times n minus 2 times over and over again until I get to 1. And what you should glean from this is that everything cancels all the way down to the 1 except for n. So your final answer is just n. What you'll see me do, though, is I typically write n factorial as n times n minus 1 factorial all over n minus 1 factorial, and I'll just cancel things out like that, and I'll still get n as my final answer. Because this is the first time I'm defining n factorial, I wanted to bring back some sigma notation for you. Just a reminder that we're plugging in 0, so it's like 2 to the 0 power over 0 factorial, and then plus bump this up to 1, so 2 to the first over 1 factorial, plus 2 squared over 2 factorial. And you will want to know some of this before you go off to a different math class or college or something like that. So just a quick reminder, 2 to the 0 power is 1, and 0 factorial is 1. So we're starting with 1, and then 2 to the first is 2 divided by 1. And then we have 4 over 2 is 2. And remember, 3 factorial is 6. 2 to the third power is 8. 8, 6. I would probably change this to be 4/3, but that's just me. So as you add those numbers together, 2, 4, 5, 6 and a third, if anybody's okay with a mixed number, that would be okay. Otherwise, an improper fraction would be 19/3. Which again, I'm not numb to the fact that your calculator will do this stuff for you. So just to give you a heads up, if you hit that math tool, there's something down here that even looks like the sigma summation, and you can set up your equation. You can even use n if you want. You hit alpha n from 0 to 3 and make your fraction 2 to the alpha, I forgot where n is, there it is, over alpha n math factorial. And I know I'm doing this fast, but I already showed you how to do it by hand. I'm just pointing out that your calculator is smart enough to do these for you, which is why I'm not too concerned. Right now we're just sort of having fun with these problems. And what we are now ready for is the binomial theorem, which right now looks scary. But it's all about these factorials. And what we need to start with is this definition right here. And we use NCR so often. By the way, sometimes we use the letter C because it's a combination. And you probably even noticed that when I clicked on the calculator. It's the first, N is a number and R is a number. It's the first number factorial over the difference of the two numbers factorial times the second number factorial. There's a lot going on, but it's really not that difficult of a process, and it's so important that they turned it into a new symbol, this symbol right here, because we use it so often in math. So there's no line, it's not a fraction, but it looks like a fraction, so that there's no line on purpose. So let me jump down here to exercise 3, and then I'll explain a permutation in a second. So how do you do a combination? That's 8C2. It's the first number factorial over the difference of the two factorial times the second number factorial, which I feel like we just did this problem. Didn't we just do that problem? Well, they switched the numbers around, but remember multiplication's commutative, so that's okay. So this first answer is actually 28. Because we already worked through it. But I do want to point out, if you use a calculator, you don't even have to hit the number first. I know some calculators make you hit the number first. You can just hit the math over to probability, that's why it's in probability. The C option, 8C, I already forgot what it was, 2. Where are we at? 8C2. You You get the same answer as right there. The reason why I was confused for a second is it's actually the same answer if you did 8C6, and that should make sense to you because if you did the difference of the two and the second number, it's the same thing as the difference of the two and the second number. The other piece I should mention is these also need to be positive integers. I think it's mentioned in your notes. And the first number needs to be larger than the second number. So this is the same thing as 10C3, which means 10 factorial over the difference of the two times the second one factorial. Now you might see me write this out like this: 10 times 9 times 8 times 7 factorial to cancel out the 7 factorials. 3 times 2 times 1. And I would probably do this in my head because I know that 3 goes into 9 3 times and 2 goes into 8 4 times. So in my head, I know that this is 12 times 10 is 120. There's a lot of tricks to doing this, and I don't want you to just rely on your calculator. Like, oh, you showed me how to use my calculator, so that's what I'm going to do. Yeah, it gives you the right answer, but you probably learn a lot more by playing around with these numbers a little bit. Because, like, not to sound super negative, but I can just look at this and I know that this answer is 1 without doing anything. And I think that's a lot better and faster for you than relying on your calculator. But the reason why I want to explain this still is because if we didn't have that rule that we established before of the difference of the two factorial, because if you were to look at this and say, oh, well, 0 factorial is 0, we'd be divided by 0 and this is undefined. That's not true. 0 factorial is equal to 1, and 8 factorial over 8 factorial would cancel each other out. So with some practice, you'll get that. So I guess I need to fix what I said. I said that the first number needs to be bigger than the second number. They can be equal to each other. So I'm glad I remember that I said something incorrect so I could fix it now. So the first number needs to be at least the same as the second number, if not bigger. Okay, so permutations. I have enough time. The only thing that's different for a permutation is we just subtract the two numbers factorial. So you never do the second number again. That's the only difference between a combination and a permutation. So what's happening on this one, and we don't have a shorthand for it. We always have 8p2. This is just 8 factorial over 6 factorial. So it's the same thing as 8 times 7 times 6 factorial over 6 factorial. And again, I know that other teachers teach this slightly different. So what some teachers will say is you do a factorial, but it's the counting principle, which we'll get a little bit more into later, is that there's two numbers of it, 8 times 7. So what I'm getting at is some teachers teach this one this way, where it's 5 times 4 times 3 times 2, and you stop once you have 4 numbers. 4 number right there. So anyway, this first answer is 56. How I usually do this problem is 5 factorial over subtracting the numbers. So it really is the same thing as just 5 factorial, but just to show you your answer with a calculator, 5 permutation 4. And notice it's the same thing as 5 times 4 times 3 times 2. It's actually the same thing as 5 factorial because multiplying by 1 is not going to change that value either. And there's a reason for that. So again, some people might explain this permutation like this: 10 times 9 times 8, because there's 3 numbers. However, the actual algebra behind it is 10 factorial over 7 factorial. Yeah, which isn't too bad because it'd be 72 times 10, which would be 720. And I'm at the end of my time, so maybe I'll just show you real quick. I'm trying to hurry. Yeah, you get the right answer.